No, we are doing limits, and also we are doing mostly derivatives. Okay, so what is this going to look like? Well, we need a good foundation of stuff in order to do this.
Are you recording?
So, yes, I am recording, so keep your side remarks to a minute. So today we're going to focus on limits, and also sigma notation, just because we need to know that. The sigma notation is not going to appear in this chapter. It's in a previous chapter, but being able to use it will help us with the limits a little bit. All right. Well, what is a limit? Well, when we're thinking about a limit, we're really thinking about what happens to the function. So you could think of this as y. What happens to the y values as x gets really close to something? Like extremely close to it. Really, really close. But not equal to. Not necessarily equal to some value. So I'm just going to draw a little picture here, and I'm pretty sure we have talked about this before. And here's some values. And let's get another picture. I'll say that's at a half. I'm just making up some values right here. These are in halves. That looks good. And let's get one more, just because. And I probably don't need all these points. All right, but we'll use this to answer some questions. All right, so small enough graph here. Let's say I want to take the limit of this function. I have a picture of it as x approaches, say, -2. All right, f of x. So I'm asking, what is happening to the y values? What's happening to the y values as x gets close to -2? So I could take a look at this, and I could go from the left-hand side, and I see that from the left-hand side, as I get close to -2, which is right here, here's x is -2, y, the function f of x, gets really close to 2. And if I go from the right-hand side, I see that it jumps down, and then it also, from the right-hand side, it also gets really, really close to 2. All right, easy enough. Let's say I have the limit as x approaches 3, 4, 5, -5 of f of x. And by my picture, if I come from the left, okay, it's getting really close to this, and as I come from the right, it gets really close to this. So I would say it gets really close to 1 as x approaches -5. Is this making sense so far?
Sure.
Sure? That's not a very confident sure. So I have my picture. Let's try this one. Okay, so that would be x right here is a 2. So let's take the limit of f of x as x approaches 2. Well, as I come from the left-hand side, see this would be the left-hand side over here, left, left. This is the right-hand side. As I come from the left-hand side, what's happening to f of x? What's happening to the function as x gets close to 2? Looks like it's getting close to negative 1/2. Negative 1/2. And if I come from the right-hand side, it's the same thing. Does that make sense?
Well, how do you know when to stop? Because I would have said it just kept on going, infinity, down.
But I'm getting, what happens to the function as x gets really close to not equal, but not equal to, some value, some number. Okay? We can do an indefinite limit, meaning with respect to infinity, but I'm not doing that. I'm getting really close to a value, 2. What happens to the function? Okay? Now, it's possible that when we go from different sides, that we get a different answer. So here's another one. This is going to be kind of a parabola-ish thing on this side. And then on this side, we'll say it comes like this. And we'll loop it back around. And then we'll stop right there. Then I'll make a jump. And have this going up. Something like that. And let's get some more pieces to this. Maybe there's an empty circle there. That means it gets close to that point. And let's get a beautiful picture here. I know how you guys like pictures. Make this really steep. Okay, so we have an asymptote here is what I'm implying. We don't have an asymptote here. Okay, let's do a bunch of limits. Alright? Let's get to the confusing ones. Let's say I take the limit of this as x approaches negative 3. And now I'm going to put a little symbol here to indicate which side. From the negative side, so from the left-hand side. So that means I'm going to get close to negative 3, but I'm going to approach from the negative side. So I'm going to come from this side right here. This is the negative side. Over here, the right-hand side, this is the positive side. So I'm saying I'm going to make x go to negative 3, get really close to it, but I'm going to come from the negative side. So if I come from the negative side, what's happening to my function as x gets close to negative 3? See, I'm coming this way. And it gets really close to here. Now, it doesn't matter that there's not actually a point right there, because I'm never actually going to reach this. I'm just going to get really close to it. So as I get really close to it, it's approaching what value? What value is this? 1. So as I approach from the left-hand side, from the negative side, as x approaches negative 3, so I'm going this way. See, I move along x, and I'm asking what happens to y? And it gets really close to 1. It's right here. Okay? But if I take the limit as x approaches negative 3 from the positive side, so from the right-hand side, see, this is right-hand side. Well, what's happening? Well, as I come from the right-hand side's over here. Okay, so I'm going to approach this way. So this stuff right here really doesn't matter. It's what's going on right around here at the negative 3 that I'm concerned with. So I'm going from the positive side. That means I'm coming in this way, you see? And now it's approaching a different number from this side. It's approaching this number if I come from the right-hand side. And as I come from the right-hand side, it's not approaching positive 1. It's approaching negative 1.
So you go the opposite way of the arrow.
What arrow?
It's a ray, right? Well, sort of.
This?
No, that.
This?
Yeah, the actual line thing, it's going up with an arrow, but the point's down at the end. Does that make sense?
Well, I'm just drawing these arrows to show you which way we're looking.
Not that, never mind.
I want to understand your question.
I don't understand.
It's like you're, hold up, I'll explain since you don't have to.
All right, Ryan is going to explain.
We're doing this one.
Okay, he's talking about this one.
We're trying from this side.
Yeah, that's what I was asking. And, okay,
And if
thank
it's
you.
if this is negative, you just do this and get to there.
Okay.
If you're looking for this point and you're coming from this side, you just
Basically, what I was asking is why didn't we go up the line? The parabolas and stuff like that.
Okay. It depends on which way I'm moving. I'm moving this positive direction. I'm moving from the positive direction this way to ask what's happening at -3. So I'm not going up this parabola. I'm not going up in this case because that would be going from the left-hand side. I'm going from the right-hand side, so it's really, I'm looking at the x-axis. And I'm coming this way. And I'm looking at the y values and seeing, well, what happens as I get close to -3? And I'm looking at the y values to see what happens as I get close to -3 from the right-hand side.
can we explain it?
No, I get that, but that's not.
Why is it not this one?
No, what? Okay, so you're looking at going this way. I get that it's there, but also why do you not look at this because that's also at -3?
No, it's
I know,
not.
but
X is -3 right here.
okay, okay, don't worry about it.
No. Are you thinking, like, because, okay, so X right here, okay, I need to clear all this because this is really, really messy. All right, let's clear all this. All right, but I don't want to clear that. All right, I don't want to clear that. All right, so we're going to get to -3 from the positive side. All right, so X right here, where this red dot is -1. And it appears the Y value has gone either infinitely positive or infinitely negative, since I was coming from, which is actually going to be the next question. So I don't want to talk about that yet. I cross over. Maybe I'm right here. Am I getting closer to -3? Yes. So what's happening to the Y value? Well, it's right there. It's about a 1. Okay. As I get over here to -2, well, X is getting now closer to -3. What happened to the Y value? Well, it's gone down, and it is now about a 0. If I go a half step more, I'm now even closer to -3. Now my Y value has decreased even more. It's like -0.5 now. And if I go one more, well, not completely to -3, but really close to -3, it really looks like that this function is getting really, 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 really close to, and in fact will equal -1.
Okay.
Okay? All right, so now we get to the confusing stuff. Well, actually that was confusing in and of itself. I'm going to clear out all this. Maybe. Clear. Without clearing this function. Okay, let's get the limit as x approaches 1 from the negative side. Okay? So 1, x is 1 right here, yes? And from the negative side, that means I start over here and I look at what's happening to the function as I get close to 1. Now really, all of this stuff's not going to matter. I'm really concerned with what's happening around here. Okay, as x gets close to 1. And as x gets close to 1, what happens to my function? It appears it is getting close to 2. Equals 2. And if I do this next limit, if I do the limit as x approaches 1 from the positive side, that's this side. Okay, x needs to get close to 1, and I'm coming from the positive side. What happens to my y value? It still appears to be approaching 2. So it's still 2. Okay? Now, let's say we look at that, let's see, 1, 2, 3, 4, 5. Limit as x approaches 5. And now I don't give you a side. Well, now I have two answers. Now I have a problem. Because if I approach 5 from the right-hand side, see 5 is right here, I would get, it seems that the function is approaching this number, which is 3. So 3. But if I approach from this side, it looks like, see, I'm coming this way, that means my function is approaching this number, -2. So which is it? That's why I need right here to say which side I'm coming from. If it's negative side, then my answer is the -2. If it's from the positive side, then my answer is 3. Okay? Now, if I don't put that there, and I say, nope, I just want this limit of 5, I don't want which side, then we have an issue. We have two answers. And that's going to be important for when we do our derivatives coming up. This means it's not differentiable. I'm not going to be able to get an answer. So when that happens, we need to cut our function into pieces and talk about one piece of the function at a time. So I can't talk about this one as a whole right there. In fact, it's not differentiable at a certain point if there's a jump, a hole, or anything generally weird. Well, what do I mean weird? If I have to lift up my pencil to draw, then it is something that is weird. If I can make it nice and smooth, like I can draw this nice and smooth without lifting up my pen, it is differentiable. But right here, I have to lift up my pen in order to get to this other side. So then it's not, right here, my function is not differentiable. Alright, we'll probably not get to derivatives today. We want to focus on the limits first. Okay, so we're going to use the same, I should have copied this before, so I didn't have to keep on undoing this. Because, oh gosh, go away. Alright, well, we'll have to deal with all that extra red for now. Let's say I want the limit as x approaches, we're going to call this point -1.5. Now, if I approach that from the negative side, so from this side, my function, let's see, is increasing because I'm going this way. And it seems to approach infinity. If I go here, same number, but from the positive side, my function is decreasing as x approaches -1.5. And it appears to approach negative infinity. You look baffled. Are we baffled?
Did we do this at the beginning of the year?
Yes, we did. We did do this at the beginning of the year. We have to relay the foundation. Get it? Or just completely build a new one. We'll do one more situation. Well, maybe we'll do a few questions for this. We'll say that's a half, so we have an asymptote at a half. Let's see here, let's get that. Okay, we'll say there's an asymptote here. And we'll say there's an asymptote here. So we have a vertical asymptote and two horizontal asymptotes. Let's say we have the limit as x approaches -2. I'm liking my -2s of f of x. This is f of x. So Negative 2 is right here, right? So since I don't give you a side, we check both sides to make sure we get the same thing. So if I check the left-hand side, see I move my eyeball, my pencil, whatever, and I get close to negative 2. X equal negative 2, not y equal negative 2. I get close to x equals negative 2, which is right here. And look what my function is. About 2.5. So 2.5. If I do it from the right-hand side, it's the same thing. I get this. And it's very important to get x gets close to negative 2, not exactly negative 2. Just really infinitely close, like it'll be this. Negative 2.00000000001. Okay. That's why I'm saying the limit. This is like the wall that I can't cross. So that's why I'm asking, what's the limit? What can't I cross? Alright, if I take the limit as x approaches, we said this is going to be negative 1/2. So negative 1/2 of f of x. If I go from the left-hand side, so I do need a left-hand side. This is from the left-hand side. What happens to my function? It gets infinitely big, doesn't it? This piece doesn't matter. Why? Because that's coming from the right-hand side. So from the left-hand side, my answer is infinity. It gets infinitely big. And if I take my limit as x approaches negative 1/2 from the positive side now, so now this side doesn't really matter that much because that's the left-hand side. I'm coming from this side and getting close to negative 1/2. And what happens to my function on this side? Well, it goes down infinitely, so negative infinity. So we want to be careful of which side we're coming from. And sometimes we're not given a side. And when we're not given a side, if we can get an answer, we don't get two different answers, then my function is differentiable. I can take a derivative, which means I'm going to get to do all the math that we're going to talk about the next few weeks. And this, Chris says this. This is Chris Matthews. Remember that character? He says, of all the chapters we did in pre-calc, this chapter is the most helpful the first year of college. So this is laying whatever foundation that you're going to be building on for your major. This stuff will come up in some level. It's a definite. And it is the harder of the material. But you can get it. You can get it. All right. Let's move on from the graphs, just temporarily, and let's talk about evaluating a limit. And when I say evaluating a limit, I mean a definite limit. No infinities or anything like that. I'm just going to give you a function and you find the limit. And it's actually, finding a definite limit is pretty easy. If I take a limit as x approaches 4 of, and then I give you a function, x squared plus 3. Now, even though x is not going to ever actually reach 4, to evaluate this definite limit, I'm going to go ahead and put in 4 into the function. So I get 4 squared plus 3 equals 16 plus 3, which is 19. Now let's think about what I'm saying. I'm not just, see, even though it works like evaluating, what I'm not doing is just, I'm not just evaluating it like you're in Algebra 1. I'm not saying, okay class, f of x is x squared plus 3, find f of 4. Okay? And now, I know this is going to be a subtle distinction, and what do? You put in 4, you do this, you get 16 plus 3, and you get 19. In this, what I'm saying, what is it actually? That's what this whole question is asking. What is the function at 4? When I ask the question of the limit, I ask what number or value does the function approach? What is it getting close to? That's what I'm asking. And yes, the answer is the same in this case, but when we do indefinite limits and when we start doing our derivatives, this difference is going to be very important from this. That subtle difference will become very, very important. This idea of getting close to something but never actually crossing that thing. We're never, see, x is approaching 4, but it never gets to 4. That's the difference between these two. Let's say I have a limit, and we're going to do this one just because things happen in your testing quizzes that cause me to wonder what's going on. So let's do this one. Very, very simple.
Where's that in?
Well, you're going to see what happens. Okay, so if I put in this -2, so this is just a method to evaluate this limit, and here's what we need to, we've talked about this before. What does this mean, this -2 squared? It means -2 times -2, which is positive 4. Alright, so we get 2 times 4, which is 8. Okay, so the limit, as x approaches -2, of this function is 8. Alright, let's do another one. Let's do a positive 2. But let's change it a little bit. Let's just say -x squared. Now, when I put in this 2 to get this limit, I don't include this negative. It's sitting out there on the outside square. Which means I'm going to do this operation of squaring before I do the operation of multiplication with the negative. So I get a negative, and then I have a 4, so I get -4. Versus, see, when this negative was with the 2, and I put it in there, it went in the parentheses, so it ended up being -2 squared. So the point I was trying to make, that has happened a few times, and it's like, what's happening? What's happened a few times for each of you is you're evaluating these two wrong. -2 squared is positive 4. 2 squared with a negative on the outside is a -4. Okay, so we want to make sure that we don't confuse those two. It is an important and subtle distinction, but we want to make sure we aren't messing that up. Alright, let's consider this one, and we may not answer this question today, but we'll have a 3 right here. What happens is x approaches 3, let's say -3, of this. And this is going to get into a problem that's going to happen a lot with our derivatives and things. And do you see what happens to our denominator? So we get -3 over -3 plus 3. -3, 0. And undefined? Like, what is that? What's the answer? Okay, so this is where our trick is not going to work. We're evaluating the Algebra 1 technique to do a calculus concept. We don't actually get to -3. We want to ask what happens when we get close to -3. See what I'm saying? So this method is not going to work because I get an undefined. I can't divide by 0. Alright, so let's just try something, and this is why we want our calculators handy. Let's try, see, and use the actual calculus concept. We're getting close to -3, but we're never going to cross it. So let's try negative 2.9999. Would you agree that's really close to negative 3? Okay, so let's try that number instead. Now we won't get a 0 in our denominator. What do we get in our denominator? When we add negative 2.9999 to 3, what do we get in our denominator? 0.000 what? And then when we do this division, what do we get? What'd you get? Okay, so they probably rounded there or something. I don't know. Okay. So negative 3 point something? That doesn't sound right to me.
Wait.
Do you have a scientific symbol there?
Yeah.
Yeah, you have a scientific notation symbol, don't you? So I guess I'll have my calculator so I can interpret it for you. It should be a rather large number.
Hold on, I probably did it.
Alright, so negative 2.9999 divided by 0.0001. And I don't get this. I get negative 29999. Okay? Alright, so is this the answer? Well, no, it's not. I want to see if it's approaching a certain number. Does it get close to something that's certain? So let's just try one more. Let's do one more decimal place of accuracy and see what happens. So we'll add one more 9. That gets us even closer to negative 3, doesn't it? If I add one more decimal place. Alright, so we'll put that in and just see what happens. 5 times, right? And then add my 3. And then I get negative 0.00001. 1, 2, 3, 4, 5. Yep. And right here, just leave that. Nothing to do right there. Okay. And then we'll do this division. And then I get negative 29999. One more. So look, I got, by adding that one extra decimal place, I got a whole, I went from the 10,000th place to the 100,000th place. I added that one extra 9. That one, it was an insignificant amount. You see what I'm saying? It's an insignificant amount. I added 0.0009 to this value to get my next answer. And look how much bigger it got. So it appears that if I do this limit, what appears to be happening, the closer I get to negative 3, it seems to be getting infinitely negative. So it's not undefined, it's negative infinity. We got infinitely big. Let's see here. Are there any other samples that we can do that we can torture you with? Nothing? Yes. I want you to do these two and just see. These are definite limits. But I'm going to give you a side. Alright, so I'm giving you two limits I want you to find, and now I'm going to define f of x. F of x is this. It's going to be negative x squared plus 4x minus 1 over 2x minus 3. And this piece is going to be this if x is less than or equal to 2. And it's going to be this if x is greater than 2. So this is a piece function. We did those at the beginning of the year. It's where a function is cut into different parts. So I have two parts on this function. So if x is approaching 2 from the negative side, which of these two will I use to calculate? This one, right? This first one. Why? Because it's defined on the interval x is less than negative 2, or less than 2. So I would put in 2. Negative because 2 squared is 4, and then I have that negative hanging out there. And then I just put these together. 3. And then I'll use this one for this because I'm coming from the right hand side. Positive values, no, it's not necessarily positive values. If I could be, it's the positive side. So the larger values, so this is defined for if x is bigger than 2. X is, in this limit by the way, in this limit the way it's written, x is always bigger than 2. Okay, it gets close to 2, but it's always bigger than 2. So that's what this function is. So I do 2 times 2 minus 3. So 4 minus 3, which is 1. We're going to do one more and then just leave the rest of this topic for tomorrow. And that is going to have to do with this other example. Okay, so I'm going to give us g of x. And I'm going to say g of x is this function. Alright, so it's this. And let's find the limit as x approaches 3. Of g of x. Alright, so what we're about to do is wrong. We get in the habit of doing the same method for every problem. And that's not as, you're going to have to learn to recognize when a certain method is not going to work. And we need to recognize it at this step. If I put 3 in here, what do I get down here? A 0. So this method, that usual method, see, this is a definite limit. I can put in the 3 and use that Algebra 1 technique. And I get all sorts of weird stuff happening. I get a 0 down here, and actually up here, what do I get? I get a 0. And then, now what's that? It makes no sense. Take 0 things and divide them into 0 groups equally. That makes no sense. And by the way, no, that does not equal 1. Okay, no, it does not reduce to 1. I knew what you were thinking. No, 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 no. Because our first problem happens down in this denominator. So, what are we going to do? And this is often what we'll need to do, is remove what's called the discontinuity. You've actually practiced this before. So actually our first step is not to put in the 3. Our first step is to, in this case, sometimes removing this continuity means to factor. So if I factored that numerator, I get this. And if I just leave that denominator alone, so I factor the numerator, I leave the denominator alone, look what happens. Those cancel. I've removed the discontinuity by canceling. So now, when I take this limit, as x approaches 3 of g of x, I get 3 plus 3. I get 6. That is nowhere near 0. Well, okay. It's not 0 though. It is not 1. Okay, neither of those answers is actually it. This is equal, right? I can reduce in fractions. If I had 4 times 5 over 4, I could cancel like that, right? And get 5. I did the same thing. So my limit is 6. If we were to graph this, function, we would see as we get close to 6, or as we get close to 3, the function gets close to 6, but some weird like asymptote thing happens. Now we have this other piece here. Notice, now, and this is why we have a difference here. X is getting close to 3, but it doesn't equal 3. Because if it equaled 3, I'd get a 2. Okay? Because it's defining it. It's like, weird things happen at this function, but I have a definition it's going to be 2 there. Okay? So, if I said this, find g of 3, you would not say 6. You would say 2, because it's defined at 2, or at x equals 3.
You are just.
Yes.